Good day to all. It's the start of another day of learning in our General Chemistry 1 Class 4, Week 3. Ma'am Maria Bernadette Espiazon will still be your teacher for this day. And today, you will learn about covalent compounds, chemical formulas, structural formulas, and models. At the end of the learning episode, you are expected to 1. Distinguish among a binary acid, a ternary acid, and a base, and 2. Represent covalent or molecular compounds using chemical formulas, structural formulas, and models. Ready now? Let's begin with our first part, the pretest. 1. When ammonium nitrate is heated to a high temperature, it forms dinitrogen monoxide and water. What is the chemical formula of dinitrogen monoxide? A, B, C, or D? Go. 2. What formula represents how many of each type of atom are in a molecule of a covalent compound? A, B, C, or D? Go. Three. Which of the following is a ternary acid? A, B, C, or D? Go. 4. Which of the following is the correct formula of nitrogen trifluoride? A, B, C, or D? Go. And 5. Which of the following is a base? A, B, C, or D? Go. Here are the answers. So what's your score? As usual, you don't have to be upset if you were not able to answer some of the questions correctly, because you will be learning about this today. Please answer now our recap before we go to our new lesson. Last time, you learned the proper way of naming binary and ternary ionic compounds. Can you still recall some of the concepts related to this? 1. Blank is a system used in chemistry for naming compounds. 2. When naming a chemical formula for ionic compounds, you write the name of the blank element first. 3. The names of binary ionic compound usually ends with the suffix blank. 4. If an element can form two ions of different charges, just like many of the blank in the periodic table, like copper with 1 plus and 2 plus and lead with 2 plus and 4 plus, the name of a compound must identify which ion is present in the compound. And 5. A number of these polyatomic ions containing oxygen atoms are named based on the root word of the central or non-oxygen atom and the suffix blank. And the answers are... Let's proceed now to our lesson. Are you ready? Reports say that air pollution plunges in the metro as people stay at home and traffic is cut by over a third due to the lockdowns implemented because of the coronavirus pandemic. A dramatic drop in the level of carbon monoxide in the air, a dangerous gas produced from vehicle emissions, was observed due to fewer cars on the road for almost 3 months. But did you know that this carbon monoxide pollutant belongs to another type of chemical compound? There are only about 90 naturally occurring elements. In comparison, there are thousands upon thousands of different compounds in nature, and more are constantly being discovered. Elements combine in many different ways to form the astonishing variety of natural and synthetic compounds that we see and use every day. Many of these compounds do not contain ions, but instead consist solely of discrete neutral molecules like carbon monoxide. These molecular compounds, covalent compounds, result when atoms share. rather than transfer, gain, or lose electrons. We can often identify molecular compounds on the basis of their physical properties. Under normal conditions, molecular compounds often exist as gases, low boiling liquids, or low melting solids, although many important exceptions exist. Because there are so many compounds, chemists have developed another way of writing chemical formulas, molecular formulas to be exact, for the covalent or molecular type. A molecular formula shows the actual number of atoms of each element in a molecule of the compound. For covalent compounds, the molecular formula represents how many of each type of atom are in each molecule. For example, the formula NH3 signifies that a molecule of ammonia contains one nitrogen atom and three hydrogen atoms. The molecular formula also gives qualitative and quantitative information about the composition of a molecular or covalent compound, including acids and bases, just like in the ionic compounds. It shows what elements make up the compound, qualitative information, and the mole ratio of the elements, quantitative information. The names and formulas of compounds will be needed in the succeeding lessons, particularly in writing chemical equations. When two nonmetallic elements form a binary molecular or covalent compound, several combination ratios are often possible. So how do we write chemical or molecular formulas for this type of compounds? For example, carbon and oxygen can form the compounds carbon monoxide and carbon dioxide, two gases that are very familiar to you. Since these are different substances with different properties, they cannot both have the same molecular formula of CO. To deal with this situation, we use a method that is somewhat similar to that used for ionic compounds, but with added prefixes to specify the numbers of atoms of each element. The more metallic element, the one farther to the left and or bottom of the periodic table, is written first, followed by the more non-metallic element, the one farther to the right and or top, with its name ending changed to the suffix IDE. The numbers of atoms of each element are designated by the Greek prefixes shown in this table, 1 for mono, 2 for di, 3 for tri, and so on. When only one atom of the first element is present, the prefix mono is usually deleted from that part. Thus, carbon monoxide is CO and carbon dioxide is CO2. When two vowels are adjacent, the A in the Greek prefix is usually dropped, as shown in these examples of molecular formulas. Some compounds containing hydrogen are members of an important class of substances known as acids. Many acids release hydrogen ions or H+ when dissolved in water. To denote this distinct chemical property, a mixture of water with an acid is given a formula derived from hydrogen plus the anion of the compound. The first type of acids is binary acids, comprised of hydrogen and one other nonmetallic element. Binary acid solutions form when certain gaseous compounds dissolve in water. They change the color of indicators like turns blue litmus paper to red and have a pH level of less than 7. Here are the steps in writing molecular formulas of binary acids. What is the formula of the acid that consists of hydrogen H+, and chlorine Cl-?